Here we have a retirement type of calculator thing to calculate your retirement. So sort of like if you're investing money and you're getting a certain interest rate and you're doing it for a certain time period, then how much is that investment going to be worth? So here an employee is making $45,000. The employee is going to contribute 10% of their income towards their investment every year. The employer will contribute 5% of they'll match it some. So overall, 15% of this employee's income is going to be contributed. So that's $6,750 per month. You'll see if I made that $100,000, then that's 15% of $100,000 right there. So I'm going to leave it at $65,000. And I think this person's salary just went up. At 6% a year is the interest rate, and for 40 years, they will have $1.5 million in their nest egg at the end of that time period. So let's recreate the future value function. I'm going to click on finance right here. So the future value, like the name of that function or the name of this in finance, what is the future value of those investments? That's where it comes from. The rate is going to be 6%. That's what they're going to earn. And notice that these are annual contributions. We're contributing annually now, not monthly. We'll look at what the difference would be if we did monthly, because maybe at the end of every month the employee wants to make a contribution and the employer would be willing to match on a monthly basis. We'll see how that would change the investment. But first, let's do it on an annual basis. Our annual rate is just 6%. The number of periods is just 40 years. The payment is that amount right there. The present value when we start out doing this will be 0. And is it going to occur at the beginning of the period or at the end of the period? End of the period is the default, so we'll leave it blank. And we get $1,508,929.16. Well, again, I got a negative, so I'm just going to come up here, and when I click up here, it tells me there's the rate, there's the number of periods, there's the payment. It's giving me a little highlight there. I'm going to put a negative right there and hit enter, and it gives me the positive. And then I could right-click this if I wanted, go to Format Cells, choose Currency, and drop off those decimal places, put it to 0, hit OK. And there we have the matching figure. What if I did it on a monthly basis? So I'm increasing the compounding period. So if you just think about that intuitively, I could either contribute a year from now, just to use a hypothetical value, $100, or I could contribute like, $8.50 a month, which would be about the equivalent in a year. Well, I would get interest after the first month on the $8.50. And at the end of the second month, I would get interest on the $17. And so I would get interest all along the line on a monthly basis, whereas on the annual basis, it's only at the end of the year. So if I was to do that financial function, future value, and the rate was that, but it's going to be every month, so I'm going to divide by 12. And the number of periods would be that, but it's going to be every month, so I'm going to multiply it by 12. And the payment was that, but it's every month, so I'm going to divide that by 12. And the present value was 0 when I started out. Monthly compounding actually gives me another $110,000 at the end of 40 years if I invest every month. So you can see the power of monthly compounding versus annual compounding right there on an investment. This is where we have what our pension will pay out over a certain period of time. So here's our nest egg right there. We're going to get this interest rate on it. We want it to pay out over 25 years. So this will be the monthly withdrawal, which we'll be able to make from our pension. Again, to calculate this one here, we're going to use the payment function just as we did with a loan, because in effect, this is kind of a loan where we have lent money to the bank. The bank has all this money, and they're going to pay us back every month for 25 years until that entire loan is paid off. Let's go on and look at one more spreadsheet here, and this is the sort of amortization schedule of the loan or the investment that we have made with the bank. So the bank's holding all of our money, they're holding that much. They're going to pay us this much every month, right? That will be our withdrawal. And the portion of that withdrawal, which is interest, will be this. So the investment will be reduced, actually the principal will be reduced by that amount, and now this is our new principal right here. So that's the way you kind of do a nest egg retirement schedule. And you can scroll down and see all the numbers all of the way to the bottom. Here's another really cool function, which is the VLOOKUP function. So if you notice up here, we have the lookup and reference category.